Section 6.6 Part 2 is about logarithmic and exponential equations, which is what we've been working on for the past couple of sections. So what we're going to focus on in this section is solving logarithmic and exponential equations in the two methods that we've learned. So we've learned that we can solve exponential equations by writing them in logarithmic form or by taking the natural log of both sides. So let's take a look at this first example. If I have 5 to the negative x equals 25, that means log base 5 of 25 equals negative x. Well, log base 5 of 25 is 2. So 2 equals negative x. I can divide both sides by negative 1. That means that x equals negative 2. So I solved this by rewriting it as a logarithm. Another way I could have solved this first problem is if you think back to our rules about exponents, if I have a to the u equals a to the v, then u equals v. So I could have rewritten 5 to the negative x equals 25. I could have 5 to the negative x equals 5 squared, because 25 is 5 squared, giving me negative x equals 2, so x equals negative 2. I would have gotten the same answer. Now when it comes to problem 2, because I have 3 to the x equals 14, well, there's no real nice way for me to rewrite, 3 to the x equals 14. 14 can't be written nicely with 3 as a base. So I can solve this two ways, by rewriting it as a logarithm. So I could have log base 3 of 14 equals x, right? Or I could have done this by taking the natural log of both sides. So I'd have the natural log of 3 to the x equals the natural log of 14. That gives me x times the natural log of 3 equals the natural log of 14. So x equals the natural log of 14 over the natural log of 3, which, using change of base theorem, is equivalent to log base 3 of 14. Okay, so either way I would have gotten the same answer. On an exam, please leave them in logarithmic form. On the homework, it may ask you to find an exact value and tell you how many decimal places to round to. So for problem 3, I'm going to solve it using this rule up here. So if I have 2 to the x minus 4 equals 32, I'm going to rewrite 32 as 2 to the 5th. So I have x minus 4 equals 5. I add 4 to both sides, and I get that x equals 9. For problem 4, I have 2 to the x plus 1 equals 5 to the 1 minus 2x. And I'm going to have to use the method of taking the natural log of both sides to solve this one. So I'm going to take the natural log of both sides. I get the natural log of 2 to the x plus 1 equals the natural log of 5 to the 1 minus 2 to the x. I'm going to go ahead and move my exponents to the front. So I have x plus 1 times the natural log of 2 equals 1 minus 2x times the natural log of 5. I'm going to go ahead and distribute, so I get x natural log of 2 plus the natural log of 2 equals the natural log of 5 minus x times 2 natural log of 5. That's just how I'm going to rearrange that. What I need to do is I need to get my terms with x's onto one side and my terms with y's without x's onto the other. So I'm going to subtract the natural log of 2 from both sides, and I'm going to add x times 2 natural log of 5 to both sides. So that gives me x natural log of 2 plus x 2 natural log of 5 equals the natural log of 5 minus the natural log of 2. I can go ahead and rewrite this as, by pulling out a factor of x, I've got x natural log of 2 plus 2 natural log of 5. That gives me equal to the natural log of 5 minus the natural log of 2. I'm going to go ahead and divide by sides by this term. So I'd get x equals the natural log of 5 minus the natural log of 2 over the natural log of 2 plus 2 times the natural log of 5. And I can simplify this, right? This is the natural log of 5 halves over the natural log of, this becomes 2 squared. 5 squared is 25 times 2 is 50 for our final answer. Again, I'm going to solve exponential equations by putting them in logarithmic form. For problems 1 and 2, what I really want to do is I want to take the natural log of both sides to get started. So for 1, I'm going to take the natural log of both sides. That gives me the natural log of 9, move that negative x to the front, equals the natural log of 3.1. I go ahead and divide by negative natural log of 9, so I can skip a step. So I have x equals negative natural log of 3.1 over the natural log of 9. I could also use change of base to rewrite this as a logarithm. This would be x equals negative log base 9 of 3.1. For problem 2, what I want to do is I need to go ahead and divide both sides by 5. That gives me 2 to the 3x equals 8/5. I'm going to go ahead and take the natural log of both sides. That means I can move this 3x to the front. So I have 3x, natural log of 2, equals the natural log of 8/5. I'm going to go ahead and divide both sides by 3 natural log of 2. So I can isolate my x. That gives me x equals 1/3, the natural log of 8/5 over the natural log of 2, which I could rewrite using the change of base theorem as 1/3 natural log of log base 2 of 8/5, and then I can move that exponent up, so I have x equals log base 2 of 8/5 to the 1/3. And you might be saying, Miss Miller, why aren't you plugging this into a calculator and giving me an exact value? Well, because these are all irrational numbers. They're numbers that go on and on and on and on forever. If I was to round them, I'm not giving you an exact answer. This answer is 100% exact. The last thing I want to talk about today is solving exponential equations by writing them in quadratic form. This is going to use U substitution, which is something we've seen before. So for example, if I have 4x minus 2x minus 12 equals 0, I can rewrite this 4 as 2 squared x minus 2x minus 12 equals 0. Now we have something in quadratic form. I'm going to let u equal 2x. That would give, sorry, not 2x, 2 to the x. That gives me u squared minus u minus 12 equals 0. And I can go ahead and factor this. I'm going to factor this by finding the factors of AC, which is 12, that add up to b, which is -1. And that's going to be u minus 4 times u plus 3. And I set that equal to 0. So I have u minus 4 equals 0 and u plus 3 equals 0. So I get u equals 4 and u equals -3. Now I can go ahead and set these equal to our original u, which was 2x. 2 to the x. If I have 2x equals 4, that means x equals 2, right? 2 squared is 4. If I have 2x equals -3, this cannot happen. We cannot take a positive number to some power and get a negative. So our only answer is x, our only solution is x equals 2. Let's take a look at example 2. I have log base 3 of x squared minus log base 3 of x equals 6. My u in this case is going to be log base 3 of x. So I have u squared minus u equals 6. I move that 6 over to the left-hand side, so I have u squared minus u minus 6 equals 0. Well, the factors of -6 that add up to -1 are -3 and positive 2. I set each of those equal to 0. I get u equals 3 and u equals negative 2. So I have log base 3 of x equals 3. So that means that 3 cubed equals x. So x is 27. Next, I have log base 3 of x equals negative 2. I rewrite this as an exponent, so I have 3 to the negative 2 equals x. Well, 3 to the negative 2, that's 1 over 3 squared, which is 1/9. So in this case, I do have two solutions.